To do code walkthrough for my recent attempt to load Imdb dataset in a graph DB, which is neo4j. I have selected for this purpose, and let me quickly introduce you to the dataset that I'm going to deal with and the structure in which I want it to be stored, and then I will show you how exactly I have used Python interface to achieve that. So if you look at the files which Imdb exposes, then there are few which I'm going to introduce here. So there is one file which is called title.aks.tsv. So we will be ignoring this one for our current for our current purpose. The important ones are the basic one, title.basic. So this file contains all the IMDb titles for which there are some info on IMDb, and it contains some fields which you can see here, what is the title of that movie, which is in original title. Then there is something called primary title, and there is a description. So this is one thing in which we are interested, like what is the title of movie and the related information. Second thing which I'm interested in, we can ignore these crew and episode, because this is I'm not interested in TV episodes for now. I'm more interested in TV in movies. So we'll just be ignoring these two for a moment. And another important file is title.principal. So this file actually relates a particular title to the persons who have worked in that title. So if there are some directors or main actors in that movie, so that one is stored in this file. So the principal file contains relation between title file, and then there is a names file. So let me quickly introduce names first before I move back to title principles. And the names file, you see, this is the one in which all the actors or other persons information is stored. So there's primary name, birth year, death year, profession, known for title, and then there is a unique identifier and const. And similarly, there is a unique identifier for each title called tconst. And in principle, these two identifiers are used to relate titles with names. Then there is also one which I used that is for ranking. So this is called title ranking. So for each title, there is an associated average rating and number of votes, which you see usually on IMDb page. Okay, so these four files I'm going to use for storing this data in our database, and the structure of data that we store will look something like this. So let me just clear this and a fresh query. So we'll be storing different movies, and each movie, let's take example of this movie, making waves, the art. So if you just select this node, it's primary information will shown, like what is the type of this movie. So it's a documentary, and what is the original title, runtime, and what is the title type, in which year it is released, 2019, etc. And then if you double click on this, then you'll see some associated people with that movie, whichever is presenting that data. So, and how they are related to this movie. So if we take this example of Gary Radistorm. So Gary Radistorm was born in 1959, has acted in this movie. I just labeled it with work name. And then if you look at the type of association, so this is self, so he has represented himself, and his ordering is one. So these are the information that we have for his association to this movie. We can take another example like David J. Turner. David J. Turner, who was born in unknown year. Maybe this information is not provided by IMDb, but if we try to find how he has worked, so he has been an editor. So he was editor because his category for this association is editor. So now this is just one way of representing that. Now the good thing is that we can relate from here all the other movies with a particular character. So let's say if you want to see in what other movies Sandra Sandler has worked, you can just double click on this. Okay, so first of all, I'm still loading the data, so it might not be that all the associated movies are present, but once all the data load is done, we'll be able to see all the movies to which this character is associated, depending on the data which IMDb has provided us. And this is like, okay, so and similarly, if you click on movie, we can see all the characters in that movie, and so on and so forth. We can just carry on this link. We will double click on it. Okay. Now this association we can find by using graph query language, Cipher, for which maybe we'll discuss in some other meeting. In our For our current scope, we are only going to discuss how we are creating this structure from this data which is provided to us using some Python code.